this is showing how you can integrate the code with gRPC. So those of you who are not familiar with gRPC, so it's a remote procedure call framework that I think Google created. That's what the G stands for. And it allows a client and a server that is written in different languages to communicate in an efficient way. So to some extent, this is a bit similar to the TCP server library we have, but here the focus is on performance. So this is not text strings that are sent, but it's a binary protocol. And also it's there are APIs provided for Python, Go, JavaScript, many languages that you can use a bit more easily than just raw JSON over TCP, which the TCP server uses. And they have lots of interesting features in this framework that can be useful if you want to build a distributed application. So we can scroll down here. There is some instructions for how to build it. The sample is a maze that is described by this state machine. So the transitions show valid directions according to this compass here. And the goal is to traverse the maze and find the goal here, basically. And the maze is walked by invoking commands from a client application that in this sample is handwritten in C++. So the gRPC server is generated by model RealTime, and the client is handwritten, currently in C++, but it could have been written in any language supported by gRPC. And this picture here shows how it works. So first of all, gRPC uses a proto language, which is their interface description language. It's actually very similar in concept to what model RealTime provides. So even terminology is a bit similar with messages and protocols. But basically you can here in a service define RPCs, which can carry data. So this corresponds to events in model RealTime that in this case don't have any data and don't return in any data. But we can also have events that carry data. And data is described by means of a message, which can have data. So it's very similar to model RealTime, where message also has one data, which can be structured and have multiple data items. So these are sending, but we can also perform an RPC that returns some data that corresponds to invoke in model RealTime. So here we have a RPC that will return the number of steps that we have taken so far in the maze. And then comes support for outgoing data, because the client may also like to be informed when some message arrives to the server which is not handled and basically should be forwarded out to the client. And the way that works is by means of subscription. So the client can subscribe for messages or events and get notified when those messages come on the gRPC server. And this picture shows how it works. So for regular RPCs, the client, in this case, it runs a command prompt in the main thread. It can make requests that are first handled by a server thread in the server. And then very similar to the Qt sample, that request is then passed to the capsule, which here is called gRPC server or my gRPC server. And it uses an external port to do that in exactly the same way as the Qt sample works. And then this capsule now in a different thread will then perform the command, and that can send some event or it can invoke some event or whatever. And then the request completes and that goes back all the way and the client can continue to work. Outgoing messages work differently because then the client needs to subscribe to a message. And when it does that, it launches a thread so it can asynchronously listen to when that outgoing event happens. And then when it happens, the server keeps a list of active subscriptions, or actually it's a map. And then when that request happens, it will just tell the subscription thread that something happened that you said you were interested in, and that can also then continue many times. And this uses a feature in Proto which allows stream requests. So it basically means that it's not just request response, but it's request and then followed by multiple responses until that the RPC is terminated. So let's look at the sample to maybe make it a little bit more clear. Let's close this sample. So the sample is very simple. It only consists of two capture parts. I have the gRPC server, and we have the maze that we already looked at. So by sending commands here on the commands port, we can control what the maze does. So let's start by launching the server, and I will do it from command line and add this OBS listen argument. So now it starts and waits to be attached to 1, 2, 3, 4, 5. Then let's attach to it. And let's run it. So then now you see now it's running and it's waiting for a gRPC request to arrive on this port 50,051. We can, just to see what happens here, we can open the instance diagram of the maze to see what it does when it receives this request. So now I will switch to the client, which I have here in another command prompt. And like I said, this is written in a plain C++ command line application, so not using model real-time for this. So I'm starting the base client, and here you see it can support east, west, north, south as simple commands. So let's try that first. So if we start by going east, you see that the state machine transitions one step to the east. We can go south. And when we do this step counter, which is a variable in the capsule, gets incremented for one step we take. Then we can go south again, but now we are at the bottom here. And if we try to go south another time, you see that it didn't work, but the client was not notified about it. And the reason is we see here that the server noticed that there is no way to go south. So there was actually an event sent by the server, but the client doesn't subscribe to that at the moment. That's why it doesn't get notified. So now let's subscribe to it by invoking the subscribe command. And then we can go south again. And now you see we got the notification here from the server saying wrong way, there is no way to go south. So in this particular time, if you remember the picture I showed, we can go back here. Now there is one subscription thread active here in the client, waiting for those outgoing wrong way messages from the server. And that thread will be kept active as long as the client subscribes to this. But if I now do unsubscribe here, now this request terminates and the thread is killed. So now we don't need to have that subscription thread anymore. So now again, if we go south, we don't get any notification anymore. We can also use one of the RPCs that return data. So by calling steps, we actually make a request which will fetch the value of this variable and return it here to the clients. So that's an example of how we can invoke synchronously an event and get data back. And finally, we can just use an event that carries data so that we have an adjust command where we can modify this step count variable to increase it by 10. And that shows how we can send data to the real-time application and have it modify something. And then finally, we can just complete the maze by going north, going east, and going east. And there we reach the goal in 16 steps. And this was also an out message from the server, but here the design is that there is no need to subscribe for this. So it's completely up to the application whether it wants to that the client has to subscribe or if it automatically subscribes, because some events may be so important that the client always should be notified about them. But that's application specific.